Hello. In this video we're going to look at the idea of interest, and we're going to look at two different kinds of interest. One that's not used very often, and it's the idea of simple interest, and one that's used very frequently, and in fact you've probably encountered it many times in your own life, and that's compound interest, where you're basically either paying or earning interest on your interest. So let's go ahead and get started with notes from the Blackboard site. All right, let's see if I can get this a little clearer. Okay, so here is where we're going to start with the idea of interest. And we're going to start with the idea of simple interest. So let me give you what the simple interest formula is, and there are actually several of them, so I'm going to write them all down. The first basic formula is that simple interest is equal to P times R times T. And what I want to do over here on the right-hand side is I want to explain what these variables are that I'm using here. So I is the interest amount. That's how much interest we're paying. Okay. P is what we call the principal, and basically that is the starting amount. And the starting amount. R is the interest rate, and what's important with the interest rate is that it must be in decimal form. If it's not, you're going to get an answer that's completely off. And that's one of the main places where students make mistakes in dealing with these kinds of problems. T is the time, and this is always measured in years. So if you don't have years, you have to convert into years. So that's our first formula. The interest amount is equal to what you start with times the interest rate times the amount of time that is accruing. You can also say that we could take A, and A is the amount. It's typically called the amount, and what that means is it's the amount at the end. So P is our starting amount, and A is our amount at the end. So if we have A equals, what we're going to do, in order to get the ending amount, we're going to have to take our principal, what we started with, and add our interest to it. So then what you can do is you can say, all right, well, I know the interest is the same as all of this, so I can write that amount equals principal plus the interest, which is principal times rate times time. And then you can do a little algebra with this, and notice that you have a P in each of those terms, so you can factor that out. And if you factor a P out of this term, you're left with a 1. Factor a P out of this term, you're left with an RT. So all of those formulas are simple interest formulas that can be used depending on the situation. So what I'd like to do is look at a couple of word problems that deal with this. So the first one is if you deposit $2,000 in a bank account, paying 5% annual interest, how much interest will the account earn in 4 years? And we're going to assume simple interest since we're dealing with simple interest. All right, but typically it will tell you simple interest. So what we're going to do is we're depositing $2,000. So we want to figure out what the interest is, okay, how much interest is in the account at the end of 4 years. So our interest is equal to the principal, which is what we start with, which is $2,000, times our rate, which is 5%, but we've got to change that into a decimal. So remember we did that in the last video. So we're going to move the decimal point 2 places to the left, make that 0.05, times T, which is the number of years. So we have 4 years. So our interest is going to be $400 on that account. All right, if we go to the second one, says use the information in the example above, so this one right here, to figure out how much will be in the account in 4 years. So now we don't want to know just the interest, we want to know the amount at the end. So A is equal to the principal plus the interest. So in our case, our principal is $2,000 plus our interest, which is $400. So our amount at the end is going to be $2,400. Alrighty. You can also do it using this formula if you wanted to. So you could say that A equals P, which is 2,000, times 1 plus R, which is 0.05, times 4, which is our T. And then if you grab your calculator, you can use your calculator for this, and you can plug the whole thing in if you want to, and say 2,000, because the graphing calculator will do order of operations for you, times 1 plus 0.05 times 4, and close your parentheses, and we get 2,400. Okay, so either way is fine. Let's go to the third example here. So you plan to save $5,000 for a trip to Hawaii in 3 years. Your bank offers a CD that pays 5.5% annual interest, and it's a simple interest. How much money do you need to put in the account now to have $5,000 in 3 years? All right, so for this one, let's look at what we know. This right here is how much we want at the end of time, so that's our A. We know the interest rate is 5.5%, so that's our R. All right, and we know our number of years is T. And what we want to know is how much money we need to put in the account now. So this is going to be our P. So what I'm going to do is I'm going to use the formula A equals P times 1 plus RT. I'm going to plug in what I know and figure out what I don't know. So I do know A, that's 5,000. I don't know P. I know R is 0.055. Remember, we always have to change that into a decimal. And our time is 3 years. So what I'm going to do is, since this is a multiplication here, I am going to divide. But before I do that, I might as well just go ahead and calculate that out. 1 plus 0.055 times 3 is P times 1.165. So I can divide both sides by 1.165. So 5,000 divided by 1.165 gives me a principal of, well, I'm going to have to round that off a little bit. So I'm going to round that off as about $4,292. So that's what I need now in order to have the money that I want for the trip later. Now let's go on to compound interest, because that's the one that shows up much more frequently. And first of all, what is compound interest? Well, it's when interest is paid or earned on the interest. Okay, so what we do is we take certain periods of time and we figure out the interest, and then that becomes our new amount. And when we find interest next time, that interest is, we find interest on that interest. So the formula for compound interest is this. It's A equals P times 1 plus R over N raised to the NT. All right, and all of these variables are the same as what we had up above. The A is still the amount at the end. The P is still the principal, or the amount at the beginning. The R is still your interest rate in decimal form. The T is still your time in years, but you have one new term in here, the N. And the N is going to be your number of compoundings per year. So for instance, if you were looking at compounding monthly, then n would be 12. If you were looking at compounding quarterly, n would be 4. If you were looking at compounding daily, it would be 365, et cetera, et cetera. Now, back in 7.4, they had a formula that you used, but I'm going to try and clear that out of your memory. It was this formula. And notice it's very similar to this one. The only thing that's different is it doesn't have the n, because what they were doing is they were letting n be 1. They were just looking at one compounding per year. So let's not use that one, because this is a much more generic and much more helpful formula to use. So let's use that formula now for some word problems. So let's go to next page. And our first problem is you inherited $15,000 from a relative and decided to buy a 5-year certificate of deposit. The Arizona Bank has a 5-year CD available with a yearly interest rate of 5%, compounded quarterly. The other bank, or another bank, Prescott Bank, offers a yearly interest rate of 4.8% compounded monthly. Which bank should you choose? All right, well, in order to figure that out, what we're going to need to do is we're going to need to figure out our amount at the end of the 5 years to see which one has a better amount. So I'm going to write up at the top here my formula, A equals P times 1 plus R over N to the NT. And then I'm going to plug in what I know. So I'm going to look first at the Arizona Bank. So I'm going to say the amount for AZ, the Arizona Bank. I'm going to start with $15,000. 1 plus, my interest rate for that is 5%. So I have to change that to a decimal. Please don't forget to do that. Very, very important. Over N, which is the number of compounding. So this is compounding quarterly, so my N will be 4. Raised to the NT, so 4 times the number of years, which is 5 years. Now I'm going to use my calculator to plug that in, because it's nice and easy to do that and get everything I need. So I'm going to plug this whole thing in, but I need to be careful about one piece. So I have 15,000 times 1 plus 0.05 divided by 4, close parentheses, raised to the, and here's where you have to be careful. This up here, this exponent, all of that has to be in the exponent. Right now, the only thing it's going to do is what is right next to it. So what I have to do around the exponent is I have to put parentheses of 4 times 5. Now I can hit enter, and there's my amount from the Arizona Bank. All right, so I got 19,230 and 56. Now I'm going to do the same thing for Prescott. 15,000, 1 plus 0.05. And now this one was compounding monthly. So my N is going to be 12. And I'm going to have 12 times 5. So what I'm going to do is I'm going to go back to my calculator. Instead of having to calculate the whole, type in the whole thing again, I'm going to hit second enter, which is going to retype it for me. I'm going to go in here. I'm going to change that from a 4 to a 12. Close my parentheses, raise to the parentheses 12 times 5. Alrighty. And that gives me 19,000. Let's see, 19,000. Oh, wait a second, I made an error. I forgot about the interest rate. That should be 4.8%. So let me change that. That should be 0.048. And quick and easy to change on the calculator as well. I'm going to go up here and make this 0.048. And I'm going to insert an 8. Sorry about that. So I get 19,059.61. So now I can check and see which one is the better deal. And this one came out with more at the end. So the higher interest rate is compounding quarterly. Even though it's not compounding as much, the higher interest rate is helping. But that's not always the case, and so you want to check it out each time. So let's go to the next problem. It says, upon the birth of a child, a parent wants to make a deposit into a tax-free account to use later for the child's education. Assume that the account has an annual interest rate of 8%. And you can't read it here, but you can read it on what you're printing out. And the compounding is done quarterly. How much should the parent deposit now so the child will have $16,000 at age 18? Alrighty. So we have our formula, which is A equals P times 1 plus R over N raised to the NT. And we need to figure out what we know and what we don't know. Notice on this one, the $60,000 is what we want at the end, so that's our A. So I'm going to plug that in for A. The P is what we don't know. We want to know how much they should deposit now. So that's unknown. Our interest rate is 8%, so I'm going to change that to a decimal. Our compounding is quarterly, so that's going to be an N of 4, raised to the 4 times, and it's upon birth until 18, so it's going to be 18 years. And now I can divide both sides by that whole mess. Alrighty. And I will get P equals 6,000 divided by 1 plus 0.08 over 4 raised to the 4 times 18. Now you can do that a piece at a time if you like. All right, you could do the inside here and then raise it to the 4 times 18 and then divide the whole thing into 6,000 if you want to. Or you can go ahead and use the calculator as long as you're careful with how you're putting it in there. So let's do that here. Move that over. Okay. So I'm going to say 6,000 divided by 1 plus 0.08 divided by 4. Raised to the, and again, I need the whole 4 times 18 in the exponent, so I'm going to put that in parentheses. And I get 1,000, oh, say, that's 60,000. I dropped a 0 here. So let me go back in, and I'm going to insert a 0. There we go. And so I get that they need about $14,419.12. Pretty amazing if you look at that. If you start with less than $15,000, by the time the child hits 18, that has quadrupled, and it's now $60,000. That's the beauty of compound interest, if it's working for you. If it's working against you and you're having to pay it, not so good. Alrighty, let's go to the last example. Let's say you would still like to go to Hawaii, but you only have $2,000 to invest in an account, and you need $5,000 for your vacation. You find an account that pays 6.5% interest compounded monthly. How long will it take before you have $5,000 in your account? So we have A equals P times 1 plus R over N to the NT. On this one, we know that the 5,000 is our A. We know that the P is 2,000. The R is 6.5%, so we change that into a decimal. It's compounded monthly, so that's going to be 12 raised to the 12 times, and what we don't know is T. So I need to solve this for T. Notice this is an exponential equation, and I want to solve it. So in our last chapter, we looked at how to do that, and what we did that with was logarithms. Before I can do that, I want to isolate this exponential. So I'm going to do that by dividing both sides by 2,000, which is going to give me 2.5. And then I'm going to go ahead and simplify this right-hand side. 1 plus 0.065 divided by 12. And when I simplify that, it comes out to about 1.005417.